Part 2 of shortcuts for quadratic functions. And these shortcuts, guys, are there for you to take notice of so that it makes it easier for you to graph quadratic functions so you can recognize them. Now, you'll notice that G is not too different from F. The only difference is this 3. Everything else is the same. Now, in standard form, more numbers are messed up because of the 3, but in the vertex form, you can see the 2 and the 1 don't change. So when we talk about the 3 most important characteristics of this quadratic function, you'll see that nothing has really changed. Starting with the vertex, we still have 2, 1. Our axis of symmetry is still at x equals 2, and our max or min is still a min at y equals 1. But we don't write y equals, we just say 1. The axis of symmetry gets x equals because it is a line. All right, now how would you find all that stuff with standard form? Well, you would have to use the axis of symmetry formula, which is negative b over 2a. And when we plug in the b, which is negative 12, and when we plug in the a, which is 3, we get 2, which you see over here from the vertex formula. And then when we need to find the y, we just take the 2, we plug it back into both of these x's, and we would be able to find the 1, which is the y value. Okay, all right, so those are the characteristics of this function g. Now let's talk about graphing it. When you graph, you need the vertex and one other point. Okay, so here's our vertex. For our mother function over here, our vertex is 0, 0. And what I talked to you guys about before is picking one other x value right next to the 0. Okay, it doesn't matter if you go above or below, above 0 or below 0. I'm going to go above 0. I'm going to pick 1 and graph that point. For my g function, our vertex is 2, 1, and so you would pick either 1 or 3 because those are right next to the 2. I'm going to go ahead and pick 3 for our g function. Now let's go back to our mother function over here. What would happen when we take 1 and plug it into this x squared? What is 1 squared? You guessed it, it's 1. And so I would get 1 for my y value for 1, and there would be my point. Take notice that that is 1 to the right and 1 up, and that's the pattern for the mother function right here. Over here, unlike the f function, because if you guys go back and watch the other video, the f function, not the g function, also did the same thing, went right 1, up 1. Okay, but this one's going to do something different. When I plug in the 3, I get a 4, which is right 1, up 3. Okay, so up 3 from the 1, that's how we get the 4. Okay, and you guessed it, that's because of this 3 right here. The 3 spaces that you have to move up from the vertex relates to this A, and that's what I want you guys to see in this part of the video. It's very important. See, after you guys get that one other point, you can easily copy it to the other side and get your parabola. Over here, you would copy this point over to the other side, and then you can easily graph it. Okay, so what if you didn't want to use the point that's right next to the vertex? What if instead you wanted to use the y-intercept? Now the y-intercept wouldn't make sense over here because the vertex is also the y-intercept. But for g, the y-intercept would actually be kind of easy to do. And if you plug in the 0 to the g function, it would either look like this if it was in vertex form, or it would look like this, which is in standard form. And I hope that you can see that if I wanted to simplify this one, it's going to be a little bit more work than simplifying this one. This one, you can see really clearly that the 13 is going to be the y-intercept. Okay, and then I put the 13 point up onto the graph, and then I can copy it over because of the axis of symmetry. Using the vertex, I can sketch my graph. So you can use the point next to the vertex, or you can use the y-intercept point. And that's an important point to know in order to graph, because you only need a vertex and one other point in order to graph. Now let's look at this function j. J is the same as g, except the 3 is negative. Everything else is the same. You'll notice the standard function changes a little bit more because of the negative 3. And this is how it goes, guys. Let's look at the 3 different characteristics. Again, the vertex is 2, 1. Again, the axis of symmetry is still x equals 2. And this time, it's not a minimum, it's a maximum. And you can see that because now we're going downwards. We're opening downwards, we're not opening upwards anymore. We now have a max instead of a min. Okay, so when we graph, as I said before, we start with our vertex. So once we find our vertex, now we just need one other point. You only need 2 points, the vertex and one other point. I've talked to you guys before about picking a number that's right next to the vertex, either -1 and 1 for our mother function, or 1 or 3 for our j function. In this case, I'm going to pick 1.
Good morning, Golden Valley staff.
Sorry about the interruption. And for my j function, I'm going to pick 3. So when I pick 1 for the mother function, I get 1, 1, just like before. And notice the pattern. It goes right 1, then up 1. And then I'm able to copy over this point over there to finish the graph. Over here, for the j function, when I plug in 3, I get -2. Now that one's kind of different. Now instead of going 1 to the right and up 3, now we're going down 3 because of that negative. So now we're able to copy the point over, finish our graph over there, and then same thing for j. We can copy the point over and then finish our graph right there. Now what if you didn't want to use the point right next to the vertex? What if you wanted to use the y-intercept instead? For this function, the j function, if I plug 0 in, this is what it would look like. And you can see for the standard form, it's very clear what our answer is going to be. Not so clear on the vertex form. Remember, you only get one of these forms when you're working with it. And of course, you can change the forms, but that's also work. So we get -11 when we plug in the 0. And so instead of using the other point, we can use the 0, -11, copy that point over, then with the vertex, we can get our graph. All right, here's our last one. Okay, for this one, now we have a fraction, a 1 over 3. It is positive, though, so it's not going to be opening down anymore. So let's talk about our 3 most important characteristics. The vertex is the same. The axis of symmetry is the same. We're back to a minimum at y equals 1, a y value of 1. And now let's talk about the tables. Okay, so we're going back to our vertex. We plug in our vertex first. Before I told you guys, you pick a number before and after the vertex. So then we would pick 1 and 3. 1 over here would put you at a point right 1, up 1. But then we run into our problem over here for the p function. The p function, because there's a fraction there, now gives us this funky point right here, which on IXL you can't even graph. You can't graph a 1/3, a 1 and 1/3 on that graph. And so that one doesn't work. And so what you want to do is you want to ask yourself a question. Your question is, how can I make the inside of this equal to 3? And the reason why we're picking 3 is because at the bottom of this fraction is a 3. The answer is 5. If we plug a 5 in right here, 5 minus 2, that'll give us a 3. When I plug in 5, I get 4, a nice pretty number. And then what's interesting is that from the vertex, we have to move right 3 and then up 3 in order to get to our next point, instead of right 1, up 1. Then after you find that 1 point, now it's because there's a 1 and a 3. That's why we're going right 3, up 3. Then after you guys find that one other point, you guys can graph the other point and then graph your parabola. So over here, we got the other point right there, and we can graph our parabola. Now, the other point that we talked about a lot was choosing the y-intercept. Now, if I chose the y-intercept for this one, things aren't going to be as pretty. If I plug 0 into the vertex function, it would look like this. This is what it would look like for the standard function. And you can see what we can get right away by looking at the standard function. We would get 7 over 3. That's not a pretty number. 7 over 3 is actually 2 and 1/3. And when I graph that, it's going to be right above the 2. And then I can graph my other point and then finish my function. Okay, the 1/3 a is the ugliest of all the quadratics. But there is a pattern, and it's that right 3, up 3 when you have a 1 over 3.